Hello and welcome to my video on experimental probability. So I hope you've already watched the theoretical probability video that I've made. If not, please take a look at that first, as that is an important prerequisite piece of information, something you need to know first, and then you can watch this video. So what's the difference between experimental and theoretical probability? Well, talking about flipping a coin is theoretical, and actually flipping a coin is experimental. So the most common form of experimental probability is when you do a survey, because you'll never be able to just know exactly the number of people that blank, whatever your question is, the number of people that like the color green. But what you can do is survey and get an experimental probability, something that gives you a probability of the next person probably picking a number. And that's the whole point. Probably. Probability. So, talking about flipping a coin versus actually flipping a coin. And this is important because, fun fact, coin toss isn't perfectly fair. It's actually, instead of being 50-50, like 50% chance, 50% chance, it's actually a lot closer to 51% to 49%. So heads is usually more likely, but there's some just interesting facts here about different chances for doing different things. But anyways, it's kind of interesting. If you're interested, you can just take a look down here at that website. That's where I pulled this information from. But there's been studies done on this, and it apparently is actually a lot less fair than you think it is, and that we can test because of experimental probability. Yeah, anyways, it's pretty cool. Another view of experimental probability would be this type of question. So let's take a look. So this is, like I said, surveys are the best example. I interviewed 50 people and asked them which they like better, pizza or hamburgers. 20 say they prefer hamburgers and 30 say pizza. So whenever I get to a question like this, I like to think of two different categories. So ham, burgers, and pizza. Well, how many liked hamburgers? 20 people. And how many like pizza? 30 people. And both are out of 50. This is important. You want to really think about all the different options so that when you add all the options, it equals 1 over 1. Or whatever your number is. So in this case, 50 over 50, which simplifies to 1 over 1. Or 1. So this is a very important little piece of information. But anyways, ham, 20 out of 50 people. So 20 out of 50 say that they prefer hamburgers, and 30 out of 50 say that they prefer pizza. Okay. So if I ask another person, the 51st person, as the surveyor, I'm guessing which one is more likely to be the person. Well, pizza is more likely. More people answered pizza. Well, how likely is it? So let's take a look at that. If we take this into a calculator, you can get a specific decimal, or you can start simplifying. So if we simplify, we can see there's 2 zeros, so we can just simplify to 3 over 5. And if we can make it go to base 10, so let's go like this, times by 2, times by 2. So 6 over 10, which is 0.6, or you can just type that into your calculator and get 0.6. So this is one way of writing probability. The other way is to times it by 100% and get that it's 60%. So this is a 60% chance that the next person will say pizza. But it's not actually a 60% chance. It's an experimental probability. It's not a theoretical one. We don't know exactly 60%. But based on our survey, we can say that it's 60%. Okay, keep that in mind, and we are going to go to this next situation. So let's see here. Let's make this another line down. There you go. The deck of cards has a total of 52 cards. In each of the 4 suits has 14 cards. I'm just going to simplify it to say it's numbered 1 to 14. 2 suits are red, 2 suits are black. What are the chances of pulling an even numbered card in a black suit? Okay, well, let's just, this is going to take a little bit of thinking here. So let's think it down to get to the answer. So there's a total number of cards, 52, and half of them, see, 2 are black, 2 are red, so half of them are black. So let's just get this number here, which is 26. 26 are black. Okay? What are the chances of pulling an even numbered card in a black suit? So, wait a second. Even and odd, even numbered card is half of them. So let's take 26 divided by 2 equals 14. So 14 are black and even. Okay, so this is important. This is the total. Okay, so what are the chances of pulling an even numbered card in a black suit? Well, we have 14 out of 52. So this is theoretical probability still, but 14 out of 52. If we try typing that into a calculator, we're going to get this answer here, 0.25, which you can also figure out is 25%. Or 1/4. And all of those answers are perfectly valid answers. So what are the chances? That's the chance. Just theoretical probability. We didn't do any testing. We didn't actually try it out. We just figured it out theoretically. That's the best way of figuring it out. But sometimes it doesn't work that way. In fact, usually you won't get exactly 14 out of 52 pulls will be that. So let's just imagine we tried it. Let's imagine we tried it. If you tried pulling a card from the deck, then replacing it 200 times, which is most likely? Well, let's just think about what 1/4 of, or 25% times by 200 times. So how much is that? Well, it's 50. Okay, so we can already get rid of A and C, because they say 25. Ignore that. Yes, it's 25%, but it's out of 200 times, not out of 100 times. So that's very important. Okay, but let's think about it. If we actually pulled 200 times, what is most likely? Well, it's most likely to be very close to 50. But it's not necessarily going to be exactly 50. Maybe it's 49 times one time, and then it's 52 times another time, then 46, and 51, and then 48, and then 52 again. Like, it could just bounce around. And maybe it's going to be 50 a couple of those times, but it's actually likely to be close to 50, but not exactly 50. Sometimes it'll be 50, and that's perfectly fine, but sometimes it won't. So it's going to be likely to be very, very close to 50. And this is where we come up with that histogram stuff that we've been looking at earlier. So 0 to 200 pulls. This is 100 pulls. This is 50 pulls. Most likely is to happen at 50, and then least likely after that. Like this. So this is number of pulls. So it's interesting. It's just interesting to notice that. Alright, so I hope this video helps you understand that what theoretical versus experimental probability is, and the usefulness of experimental probability. Hope this video helps, and good luck.